All right, good morning. It's 8 o'clock, so we'll go ahead and get started. Welcome to the week 2 Zoom session for CMIS 141. And this is the fall 2022 semester. So what I'll be talking about this morning is I'll kind of go over the material for weeks 1 and 2 in your course content. I will also be talking about your assignment, and then we'll have kind of a question and answer session where you're free to ask me kind of really any kind of programming question that you would like to ask. Okay, so we'll start off by talking about, what is Java? Java is just a programming language. You can think of it as really any other kind of language, Spanish, French, English, or anything like that. But it's a language where we can describe to the computer what we want the computer to do. That's all Java is just another language that we can talk to a computer. And so how do we do that? We create text files that describe what we want the computer to do. And I have one of them up here right here. This is a text file describing to the computer what we want it to do. Now, there are several steps that this text file goes through before it actually gets executed. We have some things called a compiler that translates this text into something the computer can understand and then executes it. That's a little bit beyond the scope of the class. We're not really going to talk too much about compilers, but just know that there's kind of an in-between step there from what you type in, which is your Java program that you create. It kind of goes through a couple of intermediate steps before it actually starts executing on the computer. And how do we make these Java programs? Well, you can use several different methods to create a Java program, or environments is probably a better word. We refer to those as an IDE. It stands for Integrated Development Environment. That's kind of what I'm using right here. The one I'm using, my personal preference is called IntelliJ. You don't have to use that one. You can use whatever IDE you want. The course material talks about using Eclipse. Eclipse is perfectly fine for making Java programs. You can actually just use Notepad and basically compile it and execute it on the command line if you want to do that. It's a little bit more difficult. If you use an IDE like IntelliJ or Eclipse, the IDE will actually help you out a lot when you're making your program. It'll give you some suggestions about, how your code should look, and we'll see some of the suggestions as I type out some programs this morning. But like I said, you can just use plain Notepad, but Notepad's not really going to give you any extra assistance other than just letting you type in your text. But it works perfectly fine. As I said, what I'll use is IntelliJ. It looks like this here, but your course refers to Eclipse, and there's nothing wrong with using Eclipse either. So this is how we create our Java program. So in here, in this file, it's called main.java, and here's where I describe what I want the computer to execute. All right, that's really the main interface of this IDE. There are tons and tons and tons of options. We're not going to go through them. Just know this is where you type in what you want to do, and up here in the top right we have what looks like a little play button, and when we run that, it actually compiles and then executes our program, and you can see it printed out hello world because that's what we told it to do. All right, so that's really the two main things you need to know for your IDE. Is this main.java is where you put your program, and the little green triangle over here is how you execute your program. Okay. So let's talk about the structure of this Java program. Well, it's in a file called main.java, right? One second. Okay, so it's in a file called main.java. As you see here, every Java program starts inside of a class. This here is a class called main. Now you have to make sure that the file name matches the class name. It's just the quirk of Java that it requires. So we have a main.java and we have a class main. And inside of this class, we have a method called main with a little m. Now, it is very important that it look exactly like this. This is where your program will start executing whenever you run it. This is how Java knows where to start, is you have to name this exactly like you see it here, this public static void main. Inside of here, the string, the brackets, and the args. And then you have this start and ending bracket. Inside of here, you can have whatever you want, right? But this is what your program needs to look like in order to properly start executing. So, and inside here, I can put whatever I want to. For example, I'm just going to have it print something. And so now when I run it with my little play button, you see it, that's what it printed out. It said print something because that's what I told it to print out. Okay. So let's say, for example, I didn't have this exactly like I needed. Let's say I left out the I, right? Now, Java does not know where to start executing your program because this doesn't look like it's supposed to. So now whenever I try to run it, it actually gives me an error. It tells me it can't find my main method. And it tells me, please define the main method as, you know, exactly what I was talking about. This public static void main and the string args. So if I change that back to what it should look like, now Java knows where to start. So now I can execute it. And now it runs just fine. So that's how you begin your programming excursions with Java. You have a public class main inside of a main.java file. Inside of this class main, you have this main method. And then this code in here is what starts getting executed whenever Java starts. This is where how Java knows where to begin execution. So now let's go into our week 1 topics. So we talk about types and variables. Types and variables kind of go together. A type is just describing what type a piece of data is, I guess. We have several different ones. We have integers, we have floats, we have doubles, we have strings. What else do we have? I think that's the main ones. At least that's the only ones you really need to concern yourselves with right now. So what have I done here? Let's make some assignments here. And then I'll describe to you what we're doing here. So this int, this float, this double, this string, that's all describing what type of data that I want to work with, what type of data I want to store or manipulate. An int is an integer. It means it's a whole number. It can be a positive or a negative, or it can be 0, but it can't be a fractional number. It can't be a decimal number. So, you know, it can be -5, -4, -32, 0, 57, 92, 1,827. You know, all these are whole numbers. Like I said, they can be positive or negative, but they just can't be a decimal number. That's what an integer is. A float is a decimal number. As you can see here, I made it equal to 2.123. And you see the little f there. I'll tell you what the f means in a second. But a float just means it can be a decimal number. So I can have decimals just like you see. They can be positive or negative. It can also be 0, 0.0, 0.3, whatever. It can be what you think might be a whole number, 3.0f. So, you know, 3 is a whole number, but since it is a float, it means I can also represent decimals with it. So I can have 3.14 as a float. And so a double is almost the same thing as a float. It can represent decimal numbers. They can be positive, they can be negative. just like a float can be positive or negative and represent decimal numbers. The difference between a float and a double is the amount of precision that you can have. So in our computers, we don't have an unlimited amount of memory in our computers, right? We have a lot, but it's not unlimited. So you can imagine a decimal number to where the decimals just go off forever or something, right? I don't know what decimal number that is, but you can imagine you have decimals that go off indefinitely forever, right? But we don't have an unlimited amount of memory in our computers. So a float and a double both represent a decimal number. However, a double basically has double the amount of memory that a float has. And so it can represent a decimal number much more accurately. So you can imagine at some point, this float is going to run out of memory and it's going to have to chop off some of these decimals at the end. With a double, you have double of that limit. Now, the limit is a lot. You can have a lot of decimals, but there is some limit. And with a double, you get a higher precision. You can have more decimals before the computer just has to cut it off. And then lastly, we have a string, which represents, just like it sounds, it's a string of characters. So here I have this string, and this is what it is. It's just the text, hello there. It can be anything we want it to be. Anything we want it to be. And we denote it's a string by having these quote marks at the beginning and at the end. That's saying everything in between here is a string. Now, what if we had this? Is this an integer or is it a string? Well, it's still a string. It may be numbers, but it's not an integer. It's still a string because I have it surrounded by this start and this end quotation mark. So it's still a string. If I take away the strings, my IDE is actually smart enough to let me know there's a problem. So you see my IDE gives me this red squiggly line underneath that's saying, hey, there's a problem here. And if we hover over it, it gives you a lot of information here that you can see. But what it boils down to at the top, it says required type is a string, but we provided it in int. So we're saying we want to use a string here, but this is an integer. It's not a string. So we can make it a string like that by putting quotes around it. So that's what the different types are: int, float, double, string. There are others, and we'll get to them at later points in the class, but those are the main ones you really need to worry about here in the first few weeks. So next to the type, the int, float, double, and string are the type. Next to it, we have what is called the variable. And this is a variable name. Here, I've named it A. This one is named B. This one is named C. This one is named D. So what a variable is, it just represents a piece of data that you want to do something with. And we can set it equal to a specific value with this equal sign. That's what we've done here. So for this whole first line, we're saying we have an integer, that's the type. We have a variable, and we're going to just name it A, and it's going to be equal to the value 1. Here we have a float. Let's get rid of a lot of these decimals here. Make it easier to read. All right. Here we have a float. It's going to be named B. That's the variable name, and it's going to be equal to 3.14f. And I said I'd tell you what the f is as we come back to it. So an f means I want this number to be a float. If we leave off the f, then Java assumes this number is a double. And so just like when we did this string is equal to a number, you know, that you can't do that. It needs to be a string, just like we had that. We're trying to say this float B is equal to a double. And you can't really do different types like that. There are ways that you can do it. Not going to worry about it in the first couple weeks. But just know if you have a variable, if you have a type variable equals, whatever it equals, it needs to be the same type. And since we have this decimal number of 3.14, just 3.14 by itself, Java assumes it is a double. But if we put a F here, we're telling Java this is actually a float number. And so this works out just fine. The next one, we have the variable double. The name of it is C, and it's going to be equal to a negative 3.14. Notice I don't have the F there because Java already treats this like a double. And then lastly, we have a string. That's the type. The name of the string is D, and it's going to be equal to this string. And the string can be whatever we want it to be, and that's fine. This is a string, whatever we want to have it. So the key thing to know here is these variable names here. This A has the value 1. This B is equal to 3.14. This C is equal to negative 3.14, and this D is equal to this string. So here in a little bit, we'll start doing different things with these. We'll start doing some, maybe some arithmetic and, doing some things with the strings and stuff like that. And you'll see why these variables are important. Now, I named these A, B, C, and D, these variable names, but there is no limit to what you can name a variable. Don't worry about the green squiggly my ID is showing. It's just saying, you made this variable, but you never use it. Don't worry about the green squigglies, just worry about the red squiggly marks. So here I'm saying I have an integer, this type. This is the name of the integer, and it's equal to 1. This is perfectly valid. Likewise, this B can be that. The C can be whatever, and the D can be whatever. Now, there are a few limitations on what you can name a variable. So a variable can have basically an unlimited amount of characters in the name. That's fine. You can have numbers in the name. That's fine. But you cannot have special symbols. So, if I try to put an @ symbol, it gives me a red squiggly. I can't use that. If I put a period, it gives me a red squiggly. We can't use that. So the variable name can be any combination of letters or numbers, except it cannot start with a number. So while we can have this, oops, let me take that out. So while we can have this and say perfectly valid name for a variable, we cannot have it start with a number. As you can see here, it turns the whole thing red. Doesn't work. Even if we try to compile it and run it, it doesn't work. It tells me, something's wrong. So the variable name, it has to start with a letter, and it can be uppercase or lowercase. You can have uppercase or lowercase letters. That's fine. You can have letters, then numbers, then letters again. That's fine. But any combination of upper or lowercase letters and numbers, but it must start with a letter. That's how you name a variable. Now the question is, would I ever use a variable named this? Whatever this is, this long string of letters. And the answer is no, because it makes it difficult to work with. Let's say you want to do something with that variable later on. You need to type it in again. So let's try to type it in again. You can ignore the fact that my IDE is trying to help me. My IDE is trying actually realizes I'm trying to type that and tries to help me. But let's say I didn't have that help. See, I would have to QWER, EWREWE, 1, 2, 3, etc., etc., etc. Right? That's hard to type out. Likewise, let's say I had a program that had 1,000,000 lines of code in it. That may sound like a lot, but modern day complicated programs have tens of millions of lines of code in it. So it's not unheard of. So let's say you have a program that has 1,000,000 lines of code in it, or even 1,000 lines of code. If you see this variable somewhere in your program, what does it represent? You really have no idea, right? You don't know what that represented. So I guess the key here, what I'm trying to say is, what you name your variable needs to be representative of what function it performs. So for example, if I name this count, okay, that kind of gives me an idea of what the variable does. It probably means it's going to count something, right? I don't know for sure yet because we haven't actually done anything with the variable yet. We haven't done any kind of math or anything with the variable. But we can kind of get an idea of what it represents. Likewise, we have this float. Let's name the float pi as float and pi as double. Probably remember from your math class, 3.14, and then some more stuff, more decimals. It's pi, right? So here, if I name this pi as float, that gives me a very good idea of what the variable represents. It is this value 3.14 as a float. But if I just have this later, let's say a lot further down in my program, somewhere down here, I have a variable pi as float. I have a very good idea of what that variable represents. Likewise, if I later down here, I have a pi as double, I have a very good idea of what that represents. It is very descriptive of what that variable actually is doing, right? So your variables need to be descriptive. I already gave you the naming rules. Any combination of upper or lowercase letters and numbers, as long as it starts with a letter, and it can be an unlimited amount of characters. But the key here is it needs to be descriptive about what it represents. And then here, if we have this string, we'll just call this str. str is kind of a shorthand for string. So if later on, if I see the variable str, I know it's going to be a string, okay? But naming the variables is kind of up to you. It's whatever helps you be able to recognize what they represent. And the last part of week 1, this is all contained within week 1, is printing things out. In Java, it's easy to print out. We have this thing called system.out.println. And then in here, you tell it what you want to print out. You can put an exact value, meaning if I put 1, 2, 3, 4, 5, 6 there, if I just tell Java to print that out, print out that number, if I run it, you see right here, excuse me, it prints out the number. That's an integer. I can have it print out a float if I want. Printing out whatever this says is a float. If I run it, there you go. It prints out that float. If I leave off the F, it means it's a double. So let's print out that double. There it is as a double. And then lastly, I can tell it print out a string. Print this string. If I run it, there you go. It prints out, print this string. Now here's where the variables become powerful. We don't have to type in the string or the number here we want it to print. We can use a variable. So let's put count here. So let's print out all of them. Pi as double. pi as float, and str. So what is our program doing here? So we've made all of these types and all of these variables. We've set their value. So count has the value 1. Pi as float has this value. Pi as double has this value. And str has this value. So now when I come down here to print, I'm saying print the variable count. So my question to you is it going to print out count, or is it going to print out the value that count is equal to? It's going to print out the value that count is equal to. This is what's going to happen. This is going to print out whatever the value of this variable is, whatever the value of that is, whatever the value of this is. So when we run it, see, we've printed out the count, which is 1. And that's correct because we said count is equal to 1. And now we're going to print count. So it prints out a 1. Likewise, when we print out pi as double, it's 3.14. When we print out pi as a float, it's also 3.14. And when we print out str, it prints out the actual string that it represents. And when we start doing the arithmetic, which we'll see here shortly, you'll see why this is a powerful concept, why I can just print out the variable name and it'll actually print out what the value of that variable is. So that's all the material for week 1. Week 1 was pretty short and to the point, but it was all about types, variables, and setting them equal to values, and then printing stuff out. For week 2, we start talking about input and arithmetic and test cases. Test cases I'll cover at the very end because it directly relates to your assignment. But we'll start off with arithmetic. All right, so let's get rid of some of this stuff. Oops. First number. Let's say we have a variable. It's going to be an integer called first number. So let's just call it number. And we set it equal to 1. Let's do a printout. Now, when we run this, so we said there's an integer, it's called number, it's equal to 1, and then we're going to print out number. Like we just saw, it should print out 1, right? There it is. But you can do math operations here as well. So instead of having 1, we could say 1 plus 1. That does exactly what you would think it does. 1 plus 1 is equal to 2. And so this number variable is going to be equal to 2. Let's run it. There you go. It's 2. So what are the different math things we can do? In Java, we can do, plus, minus, multiplication, and division. Those are the big ones. Those are the only ones we're going to really worry about right now. Well, we'll actually also look at plus, plus, and minus, minus. The plus, plus, and minus, minus are really just shortcuts, but we'll talk about them anyway. So let's describe what they do. The plus is addition. If you don't know yet, you should have gotten this from your course material. Whenever we have 2 slashes to start a line, it means this is what we call a comment. It means it's just something for us as humans to read and help remind us of things. This is not code that gets executed. The computer will completely ignore any line that starts with a slash slash. It's just called a comment, and it's only for us. So I'm just putting some comments in here to let me know what's going on. So these are our arithmetic. So the plus is addition. The minus, of course, is subtraction. We have a star and we have a slash. The star is multiplication, and the slash is division, right? So if we have our number 1 plus 1, we already saw it's 2. Let's say if we have 5 minus 7, that should give us a minus 2. We run it. There you go. It's a minus 2. Let's do multiplication. 5 times 7 should give us 35. There we go. And then let's say 50 divided by 5. Oops, not times 5. 50 divided by 5. That should give us 10, right? You run it. There you go, 10. So that's your simple addition, subtraction, multiplication, and division. Of course, you can put more than one on a line. Minus 6. So what is this going to be? You actually, we're not doing a math class here. This is, math stuff you should have picked up in middle or high school. But, we have the order of operations. Was it PEMDAS? Do a quick math lesson here. Division, subtraction, right? That's our order of operations, meaning what this is, parenthesis. I don't even know if I spelled that right. This is exponent, multiplication, division, addition, subtraction. This is just a basic math concept, and Java follows this these kind of rules. And what this is saying is, what order are these math operations done? So do we do the 5 minus 6 first, or do we do the 50 divided by 5 first? Well, if we look here, I really wish I'd spell that right. So first, we do anything inside of a parenthesis. There's nothing inside parenthesis, so nothing happens. Then we do exponents. There's no exponents. Next, we do multiplication. There's no multiplication. Then we do division. So first, we do this division. So this is going to be equal to, we do the division first. 50 divided by 5 is 10. Now, that's what we have left over. Then we do addition. There's no addition. Then we do subtraction. So the subtraction is left over. So this should give us an answer of 4. Promise that'll be the last time we do any kind of little math class. But this should give us 4, right? So let's run it. There you go. It's 4. So let's do 50 divided by 5. Let's put the parenthesis here. So now we do the parenthesis first. So first it's going to do 5 minus 6. So that'll be -1. So we're really going to have 50 divided by -1. We run it. Of course, we get -50, which is right. All right. That's the only time we'll do the little math class on order of operations. But something key I want to point out to you here is, when we did the 50 divided by 5 and we ran it, actually, let's make the number smaller so it's easier to look at. When we do 50 divided by 2, 10 divided by 2, it gives us a 5. And that's correct, right? That's correct. 10 divided by 2 is 5. What if I do 10 divided by 3? And this is a common thing across many programming languages, not just Java. But it's called integer division. What we're saying here is our type is an integer. This number is an integer, and we're dividing by an integer. And how do I know it's an integer? I know it's an integer because it's a whole number and it doesn't have a decimal. If it has a decimal, the division works differently. But when they're all integer numbers, something what you may consider strange is going to happen. When we say 10 divided by 3, what is the answer to that? Just on a piece of paper with a pencil, if we do that division, we get 3.33333 forever, right? But what happens when we're taking an integer and dividing it by an integer? What happens is we only keep the whole number. So it tells us the answer is 3. If we do 10 divided by 4, you know, on paper, that's like 2.5, I think, right? But when we divide integers, we get just the whole number part. That's what we call integer division. When you have a whole number and you divide by a whole number. Now, if we are interested in that fractional part, if we need the 2.5 answer, then you can't use the integer. You need to use either a float or a double. Let's use a double, number as double. And now we'll take the 10 divided by the 4. And let's print out this number as well. Number as double. So what's going to happen here? Am I going to get the 2.5? Let's run it and see. I actually get 2, and that's right for number because it's an integer division, right? But for the number as double, we're getting 2.0. You know, how does that make sense? Why is that not 2.5? The reason is right here, we have a double. The name of it is number as double. It's going to be equal to whatever this is. Java is going to perform this calculation first because that is what the variable is equal to. So what is this calculation? This is still integer division because I'm taking an integer 10, a whole number, and dividing it by an integer number, which is 4. So this is still integer division. Even though I want to save it in this variable, the variable is a double, but this math computation is still integer division. Well, let's fix that. You can just change one of them to a double. So now it is no longer integer division because this is a double. So now let's run it. As you see, we now get what we expect. 2 here for this one because it's still integer division. But now I'm no longer doing integer division. I'm working with decimal numbers, and it gives me the decimal answer that I expect. And division is really the only situation you need to worry about that. All the addition, the subtraction, the multiplication all work perfectly fine. But this division is where you have to be careful on if you're doing integer division or if you're doing basically decimal division. The decimal division will give you the decimal answer you're probably expecting. The integer division will only give you the whole number part of the answer. So those are our different operators: plus, minus, multiplication, division. Oh, I told you there's 2 more. We have plus, plus, and minus, minus. Before we get to that, let's show you that we can do this math stuff with variables as well. So we'll have number, let's call this the first number. We'll have a second number. So let's say we have an integer variable that's equal to 3. We have an integer variable that's equal to 4. Let's have a third number, a third integer variable, and we can do math with the first 2. We'll say first number plus the second number. And then we'll print out the third number, right? So we have an integer variable equal to 3, an integer variable equal to 4, and then we have an integer variable, and it's going to be equal to the other variables added together. Here's where, well, any programming language is powerful, is you can do stuff. I say stuff because here we're doing math, but you can get more complicated. But here we're doing math with the two variables. So let's print this out, and this should give us 7, right? And there it is. It gives us an answer of 7 because we're saying this variable is equal to the first number plus the second number. Well, the first number is 3. The second number is 4. If you add them together, you get 7. And so that third number is equal to 7. And the cool thing is that you can change the first or second number, and the third number will be updated accordingly. Because I changed this value of first number, this value is different. So now this calculation is different. And the third number will be the new value. Let's run it. There you go. Third number is now 13. Is that correct? Well, 9 plus 4 is 13. So yeah. Let's say if we do a subtraction here, what are we going to get? What? 9 minus 4 is 5. There you go. It's 5. If we do a multiplication here, 9 times 4 is 36. There you go. We get 36. And if we do a division here, this is 9 divided by 4. But remember, these are integers. So 9 divided by 4 in integer division is going to be 2. There you go, it is. And of course, we could make this one a double and make this answer a double. Now, 9 divided by 4 is 2.25, right? So the key here to remember is you can do these this math, the plus, addition, multiplication, division, you can do that with the variables. Now, I showed you what the shortcut we were going to do with the plus, plus, and minus, minus. So right now, we just have first number is equal to 9. And we print out, we get 9. It's actually, we can do a first number plus, plus. What that does, it just adds 1 to first number. It's just a shortcut for this. Same thing as first number equals first number plus 1. Those two are the same thing. First number plus plus is the same thing as just adding 1 to itself. If we run this, of course, we get 10, which is correct because it starts out being 9. We add 1 onto it, and it becomes 10, and we print it out, and we get 10. Kind of the same thing as that. If we put minus, minus, it's the same thing as subtracting 1. If we run that, we get 8. Okay. So that's the arithmetic operations with numbers themselves, like 9 plus 8, or if we do arithmetic with the variables, just like this. All right. All right. The last thing we'll talk about this morning is input. All right. And it's the last thing for your week 2 content, and then we'll talk about the assignment. So let's talk about input. So the way you get input from Java, usually you don't have to do it this way every time, but this is the most common way, and especially for beginners. So we have a thing called a scanner. A scanner is just a way that you can get input from the system. This scanner is actually the type. I told you, we have types of integers, floats, doubles, and strings. Well, this scanner is another type. It's a type that is more complicated than just a simple number, but it is a type that lets you get input from the user. And we make one like this. New scanner, we do system.in. What this is doing, it's creating this new variable scanner. Scanner is the type. Lowercase scanner is the variable name. Like I said, you can name that anything you want, but we're going to name it something that makes it descriptive of what it does. And it's going to be equal to a new scanner. as you progress in the Java class, you'll see this new word all the time. What it's doing is when you have a complicated variable, I say complicated because, or complex is probably a better word. You know, you have these simple variables of an integer, float, double, string. Those are all simple variables, and we didn't have to use this new concept. But when you have these complex variables, these complex types, you have to make them equal to a new one. So we say it is equal to a new scanner, and then inside of here, we have this thing called system.in. Don't worry too much about it at this point in the class. We'll get into it in later weeks. But this is just saying we want this scanner to be from the keyboard. That's what this represents in Java, is just keyboard input. Okay, so what can we do with the scanner? Well, we can let the user type something in and save it in a variable. See what that looks like. Let's just say I have string s. We can just have scanner next line. There we go. So what's this doing? Let's make some comments in here. Create a scanner to read from the keyboard. Put some comments in here. And read a string from the user typing, typing on the keyboard. And then at the end, print out what the user typed in. So at the end, do system.out.println, we'll print out user typed in, and then we'll print out what they actually typed in. The str. Okay. So what's our program doing here? So we're going to make this scanner object. It's going to be reading from the keyboard. When we do this scanner.next line, it means we want to get what the user typed in on the keyboard. And we're going to save it in this variable. So we have a variable, the type is string, the name is str. It's going to be equal to whatever the user types in at the keyboard. And then here we're just going to print out, the actual string user typed in. And then on the next line, we're actually going to print out whatever is in the str variable. Let's run that. There we go. It may not look like it's doing anything, but it's actually waiting for us to type something in, right? Because it's waiting for us to type something in. So I typed something in on the keyboard. Enter. There you go. So now it read that from the keyboard. Excuse me, it read from the keyboard. It saved it in this str variable, and then I print out these two things. And then here you can say that's where I typed in on the keyboard, and then it printed out the user typed in. I typed in something on the keyboard. That's what I typed in. If I run it again, let's just put my name. And the user typed in Dan Steffi. Maybe that gives you a hint of why this is useful. So instead of just a generic string, let's have them type in their name. And then at the end, we'll display their name. Yeah, maybe this looks like a slightly more useful program. So if we run it, there we go. There you go. Name, Dan Steffi, right? But there's a little bit of a problem here. You know, whenever we run the program, it looks like it's just paused waiting there. You know, what's going on with the program? If a user is using this program, they probably don't know to type in their name here, right? So let's tell them to do that first. System.out.print, enter your name. So now when we run this, it's telling them what to do. It's saying enter your name, because we did this right here. We printed this out to the screen, enter your name. So that gives the user a good idea of what to do. Okay, well, let me type in my name. And there you go. It then read it from the keyboard and then it printed out the name. All right, so that's the name. So instead of read a string, we're going to get the comments to be enter your name. Instead of just a string, we can also get integers. Enter your age, right? Let's have an integer age is equal to scanner.nextInt. Oops. Let's tell them to enter their age though. System.out.print enter your age, right? So let's see if this works and then we'll do an explanation of it. There you go. Run it. So enter your name. All right, Dan Steffi. Enter your age. Don't worry about how old I am. Oh, we forgot to print it. System.out. Dang it. System.out.println age. Now, when we run it, enter your name, Dan Steffi, enter your age, 33. There you go. So we're able to get integers. Likewise, we can get floats or doubles. We're not going to put too much effort into this. Float FFF is equal to scanner.nextFloat. We're going to have double DDD is equal to scanner.nextDouble. Then let's just print those out and then we'll wrap this up. FF system dot not string system dot out dot println DDD. So as we execute the program, we'll go through it line by line. So I'm executing the program. So it starts right here in main. It makes this scanner to read from the keyboard. It prints out, enter your name. That's what it's done right here. Now I have a variable name of type string. It's going to be equal to the next line. So it's waiting for me to type in the next line. All right. So I do that. Now it goes here. It prints out, enter your age. That's what the program is doing, enter your age. It's waiting for me to type in an integer. From this scanner, which is the keyboard, it's going to get the next integer typed in. So, okay. Now, we didn't do any more print statements. That's fine. But now the scanner is waiting for you to type in a float. Let's type in a float. Now the scanner is waiting for you to type in a double. Let's type in a double. And there you go. Then at the very end, it prints it all out. It prints out the name, which is what we typed in. It prints out the age, which is what we typed in. It prints out this float variable, which is what we typed in. And it prints out this double variable, which is what we typed in. Last example we will do with input and addition, and then we'll talk about the assignment. Let's delete most of this stuff. Let's make a simple calculator. Okay. Get first number. So we'll have an integer first number. It'll be equal to whatever the user types in. We'll tell them what to type in. Enter first number. So we're going to have the user type in two numbers and then we're just going to add them together. Get second number. Make sure we change that. Second number. Change the variable. So we're making our scanner. We're going to print out, enter your first number. We're going to get the first number integer from the keyboard. We're going to print out, enter a second number. We're going to get that integer second number from the keyboard. Add them together. So have enter answer is equal to first number plus second number. And then we'll print out the answer. print answer is. So there, we have made an extremely simple calculator that can only add two numbers together. But you can imagine you can make this more complicated. Instead of add, you could do subtract. Instead of subtract, you could do multiply, whatever you wanted to do. But we're just going to add them together. So let's run our program. There you go. It asks us for the first number, 2. Asks for the second number, 3. And says the answer is 5. There, we have an extremely basic calculator. Let's run it again. Any numbers you like. Oh, that's actually too big of a number. A little bit beyond the scope of the class right now, but just like we talked about with floats and doubles, a float only has so much memory, a double only has so much memory associated with it. And so you can only represent so big or small of a number, right? Likewise, an integer has a limit to the number that it can represent. It's somewhere, I think it's around somewhere around -2 billion to +2 billion is the biggest an integer can represent. There are other types you can use that can represent bigger numbers, but for our class, integer should be it. But so if you look at this, this is 1, 2, 3, 1, 2, 3, 1, 2, 3. This is like 345 billion. That's too big for an integer. So that's why my program crashed. Let's try it again. The first number is this, the second number is that. You add them together, and that's the answer. All right, so that's all of the material from weeks 1 and 2. I want to take just a couple minutes to mention a few things about your assignment. Let me bring it up on my screen. So for your assignment, it's really cut and dry. The assignment describes very specifically what you have to do. But you have to make a Java program, and it needs to do some input from the user, and it needs to do some kind of mathematical computation, and then it needs to print the answer. Well, that's exactly what we have done here already, right? We got some input from the user. We did some kind of mathematical computation, and then we printed out the answer. Now, the mathematical computation you need to do for your assignment is a little bit more complicated than addition, but it spells out pretty well in the assignment how to do the mathematical computation. So really what you need to do, you need to take this example that I've done here this morning and adapt it to do what it's asking you to do for the assignment. So with the assignments, and this will apply to all assignments, not just this assignment, but for all of future assignments, you need to keep some things in mind. One is what I call the specification. That means the instructions in the assignment, they need to be followed exactly. Whenever I grade assignments, I grade them harshly. I will be honest with you. I grade them exactly according to the specification. They're graded fairly, but the grading is strict, meaning you need to follow exactly what the instructions are telling you to do. Meaning, if the instruction says have a variable name of ABCD, then your variable name needs to be ABCD, if that's what the instruction says to do. If you put something else as the variable name, then you will probably lose a point or two for not following the instructions, because the specification told you to name something very specifically. So if it says name it ABCD, you need to name it ABCD. If it says the variable is an integer, you need to make an integer. If you put a float here, you will lose points if the instruction said to make it an integer. Follow the specification. Likewise, later as we go on in the course, we'll be making other classes. Right now, we just have this one class called main. Later on, we'll be making other classes, and if it says to name the class a specific name, it needs to be named specifically that. Uppercase or lowercase letters do count, meaning uppercase main is different from lowercase main. Those are not the same thing. So if the instructions say uppercase main like that, then that's what it needs to be named. Now, if the instructions does not specify, that's when you can kind of make the decision on your own. But if the instruction is specific about how things are named or what order things need to happen in, then you need to do them in that order, and they need to be named that specific thing. You will end up losing points if you do not follow the specification exactly, because I will be grading strictly off of that specification. Now, the last thing I want to mention for the assignment, and it's actually part of your week 2 material, but it applies to this assignment and all future assignments. It's what we call test cases. So let me show you what test cases look like. Every semester, people mess these up a lot. Do I have the... No, I don't have a spreadsheet program on here. Your test cases are best done in a spreadsheet. Let me get a spreadsheet up going here. Ooh. One second. So I want to show you exactly how to do this because it's going to be important. All right. Chat. Just give me a second here to set this up. Let me change my screen sharing to show everything. Screen 1, screen 2. Let's do screen 1, share. All right. So you should be able to see like my program here, as well as this spreadsheet. You know, I'll have to toggle back and forth between them. So first we'll talk about what a test case is, and then we'll talk about why it's important. So with the test case here, it's basically a spreadsheet, or it can be a table. You could just put it in a Word document as a table, but you will have the following columns in your test cases. We'll have a case number, we'll have inputs, we'll have the expected output, we'll have the actual output, and then we'll have the result. Let's expand these out some. So what goes in here? So with the case number, it's just sequential numbers, 1, 2, 3, 4, 5. And I will tell you, for all of your assignments, you need to have at least 5 test cases to test your program with. So whenever the assignment says submit test cases for your program, you need to have at least 5 test cases. And this is what looks like what you should submit. So the input is going to be different for every program. And this is, what are you as the user providing to the program? What are you inputting to the program? So let's do some test cases for this simple calculator we made here. So for the simple calculator, what are the inputs that the user is providing? Well, the user is typing in a first number and they're typing in a second number, right? That's what the user is typing in, right? So to test our program, what are we going to type in? Well, let's just say we type in 2 and 5. We don't type in 2, 5, but 2 is the first number we're going to type in and 5 is the second number we're going to type in. Okay. What could be the input for the next one? Let's say we do a -3 and 3. -3 and 3. -3 and 3. There we go. Let's say we have 10 and 57. 10 and 57. We'll have -11 and 12. And then we want to test 1, 1, 1, 1, 2, 2, 2, 2, 2, whatever. Okay. So this is saying each time we test our program, this is what we're going to type in as input. Let's see if I can make this bigger. Yeah, there we go. That looks better. Easier to read. So now the expected output is, if we type this in, what is the answer that we expect our program to tell us? Now, this is extremely key here. Do not run your program to figure out what the expected output is. To figure out the expected output, you need to kind of do this by hand. You can use a calculator if you want, but do not use your program to calculate the expected output. After we fill out this table, I will explain why that's important. But so we know our program just adds two numbers together, right? So if we give it 2 and 5 as the input, what do we expect the answer to be? We expect the answer to be 7. So that's 2 plus 5. If the input is -3 and 3, we expect it to be 0. If it's 10 and 57, we expect it to be 67. If it's -11 and 12, we expect it to be 1. And if it's this right here, 1, 1, 1, 1, and 2, 2, 2, 2, we expect it to be 3, 3, 3, 3, 3, 3. Those are what we expect our program to produce whenever we execute it. All right. So now we get to the actual output column. Now this is where you actually run your program and you type in here, what is the answer that your program gave you? So let's do that. Let's see, I can't get both these on the screen at the same time, unfortunately, but let's put the input of 2 and 5. Let's run our program with 2 and 5. It says the answer is 7. Let's put 7 in our spreadsheet. And now we have the result column. And then the result column, we put, was it successful or not? And by successful, I mean, does the actual output match the expected output? In other words, did our program accurately compute the answer? If the expected and the actual match, then the answer is pass. This result can be a pass or a fail. So it passed this test case, right? My program gave the answer that I was expecting. Okay, let's do the next one, -3 and 3. If I run it, do -3 and 3, the answer is 0. We put the actual output was a 0, and that passes. Let's do 10 and 57. 10 and 57. The answer is 6. Our program says it's 67. And that matches. Let's do -11 and 12. And yes, this may seem monotonous and repetitive, but you need to do it for every single one. -11 and 12. If we run it, -11 and 12, it tells us the answer is 1. And that matches. And then we'll do our last one. We run it 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2. It tells us the answer is 3, 3, 3, 3, 3, 3. And that matches. So since all of our test cases match, it's a good indication that our program is functioning correctly. So this is what a test case table looks like. This is what should be included with every single assignment that you do. If you do not have all of these columns, or if you do not have at least 5 test cases, then you're going to end up losing some points. So let's talk about why a test table is important. So let's say for some reason, let's say I have a really complicated program, right? Let's say I wanted to make a program that just added 2 numbers together, right? this program adds two numbers. So let's say I made a program that adds two numbers together. But let's say I made a mistake in my program. Instead of adding two numbers, I accidentally put in subtraction. Okay? It's a typo. It's a bug in my program. Let's delete out the actual and the result. So I'm still expecting this output because I'm expecting my program to add numbers together. Now, I made a mistake here, but let's say I didn't realize I made a mistake. So I'm still expecting my program to add numbers together. Okay, well, let's do my test cases. Let's try out 2 and 5 with my program. If I run it, if I put in 2 and 5, it gives me an answer of -3. I put in -3 here, and look what happened. The expected output does not match the actual output. This is a fail. If you have a fail, that means one of two things. Either you incorrectly computed the expected output. Remember, this should be done by hand. Or your program incorrectly computed the output. So something has gone wrong here. So what I would probably do, I would come back to my inputs and I would do this calculation again. Okay, 5 plus 2, that is 7. So the expected output should be 7, right? But my program is giving a different answer. That means there is something wrong with my program. And that is the entire key and the entire reason for test cases, is to help identify that your program has a bug in it, that your program is doing something wrong. So I look at this, and you can go through the rest of them. I think this would give -6. This would give like -47. This would give like -23, and then -1111111. You know, if you ran it through your program, all of those would be a fail. So this tells you something's really wrong with your program. So we're like, okay, we need to go look at our program and we need to fix whatever the bug is. So we started going through our program and we realized, oh, here is our bug. I accidentally put minus when I should have put plus. So now I've corrected the mistake in my program. After I correct the mistake, we need to delete the output, the actual output and the result again. Why? Because it's different now. So now if we run it, and we're only going to do it for the first test case to save some time here. So now when I run my program, I do the same test case again, 2 and 5. It gives me the answer is 7. Answer is 7. And now it's a pass. And we're not going, you will, for your assignments, do the rest of the test cases again to cut down on time. We're not going to do it right now. But that is what a test case looks like. That's how to do a test case. And that's the importance of a test case, is to identify somewhere in your program that you may have a bug. Let me tell you the one other way that you will lose all points for a test case. I see people do it every semester, even though I tell them not to. If you kind of cheat on your test cases. So let's go back. Let's put the bug back in our program. Excuse me. So instead of addition, I accidentally did multiplication. You know, the assignment told me to do addition, but I messed up and I did multiplication instead. All right. So let's say I want to be lazy. So let's say we have the same test case numbers. We have the same input. So now, I don't want to figure out what 2 plus, I don't want to figure out what the expected output is. You know, for this program, it may seem really easy because our program is supposed to just add two numbers together. But let's say it's an extremely complicated program. And let's say you want to be lazy and you don't want to do the computation yourself. So you're like, you be arrogant. you think that my program does not have any bugs in it. My program works just fine. So you do this test case 2 and 5. You do not manually compute the expected output. Reminder, this is, I'm telling you what not to do. So instead of manually computing the expected output, you just run your program, put 2 and 5 in here. It says the answer is 10. And so you just put 10 for the expected output and the actual output, and you say it passes. So what have I done wrong here? Is this isn't really the expected output. You know, if you do it by hand, if you do it manually, that's not correct. But if you took the easy way out and were basically too lazy to manually compute it, you were a little bit arrogant and you assumed your program had no bugs. And so whatever your program said the answer is, you just copy that into the expected output and you say it passes. But this is wrong, right? This is not what the expected output should be. And it should not pass, right? So this is where you can go extremely wrong with your program. And if I catch you doing this, then at least for the test cases portion, you will get 0 points for, you know, whatever the rubric says is the point allocation for test cases. It's really easy for me to see when you've done this, because whenever I look at your code, I see that you made a bug, you made a mistake. And so if you have a bug in your program, but these still say pass, I'm going to know that's what you did. Okay. And plus, if you do this, it tells you that it passes. It tells you there is not a bug in your program, but there is, right? That's really why it's important to do these test cases correctly. All right. And it's very important for your assignment. Okay. So that is all of the material for weeks 1 and 2. That gives you a good idea about how to start working on your assignment 1 and discusses the importance of test cases and how to do test cases. So I'll go ahead and open it up for the next few minutes for anybody that may have any questions they want to ask. It can be any programming related question or anything about the class or any of the content or the assignment. So the floor is yours to answer, to ask any question you have.
I got a question. For the test cases that we do that are fail, and then, you know, we fix the issues and then we do the test case again, would you like us to include the fail and the passes, or just the passes after we fix it?
Just the passes after you fix it. You know, if you have the fail here, you know, if we do this like it should be done, if you have the fail here, once you hit one fail, you should really kind of stop there and go back and figure out what's wrong in your program. After you correct it, then just do the test case again and make it pass. Really, I don't need to see any fail on the test cases that you submit unless they just failed and you didn't feel like fixing it. If you didn't go back and fix it, then sure, you can leave it as a fail there. But you know, the expectation would be if your program has a bug in it that you should fix it, because if there is a bug in it, then you know you'll probably lose points if your program doesn't perform correctly. So fix the problem and then change it to a pass.
Thank you. Also, I got a weird question, but why does the class name has to match the file name on Java? Like, what is exactly that works in there that it just won't run or give you like a weird error if it doesn't?
Yep, it has to do with the compiler. So your IDE, you know, if you're using this IntelliJ, which is my favorite, or if you use Eclipse, or there's another one called NetBeans and stuff like that, they hide a lot of the compiler stuff away from you. so that, you just click on a button here and a bunch of stuff goes on behind the scenes that you don't have to worry about. What's going on behind the scenes? Actually, we'll go ahead and do it. All right, let me find this main.java file. We'll show you some behind the scenes stuff and why that's important. Source, let's see, source, CMIS. There we go. So there's our main.java file, right? And we can look at it. We look at it. So that's what it looks like. That's our main.java file, exactly what we typed in, right? So what's going on behind the scenes in your IDE is it's compiling it and then running it for you. So when you compile it, it's actually running this program called JavaC, stands for Java compile, and then the name of the file. All right. So we run that. Oh, I don't even have it installed. Well, I can't show you right this second. Actually, I probably can. Sudo apt install default. I really would like to show you this if it doesn't take long. Well, that's going to take a couple. Well, it's taking a couple minutes. Basically, whenever the reason why the class name and the file name has to match is because that's what the compiler is expecting. Whenever the compiler compiles your main.java file, it makes it into a binary file called main.class. And so whenever you try to run the program main, it expects the class name within there to be main. It's just a way that Java knows where to start. So if we look at it now, so I have my main.java, I compile it with JavaC, main.java. And now if I look at my files, I have this main.class. There's my source file, my main.java, but we have this compile class, main.class. And so we can run it with Java and just main. So if I do that, my program is working fine, right? Just like that. But let's say if they don't match, where's my IDE? So if they don't match main, call it man, whatever. Instead of main, let's go back to here. Let's remove that main.class. So right now we just have the main.java file. If we look at it, there, the class name is man, meaning it no longer matches the file. So if we try to compile it, main.java, it gives me the error. So class man should be declared in a file named man.java. That's why the class name has to match the file name that it's in. Does that answer your question?
It does. I appreciate it. It was just kind of weird how I guess I was putting like a lowercase and it just wasn't working.
Yep. Yeah, the uppercase and lowercase letters do matter. Like uppercase MAN is different from lowercase MAN. All right, next question.
Hey, good morning, Professor.
Good morning.
Thank you for the class. Thank you for your explanation. This is really helpful. But I just wanted to ask if you were going to send this recording because there was a lot of information on here and.
Yep. Yeah.
Right.
The session is recorded, so I usually get it posted up later the same day. So sometime this afternoon, you all should get an email with a link to where the video is located at.
All right. Thank you.
Actually, what I'll do, I'll post the video in the class announcements, and then I'll send an email that says, hey, the video's on the class announcements, go check it out.
All right. Thank you.
Yep, no problem. And that'll be the case every week. Every week, I will do one of these sessions, and the videos will always be recorded and usually posted later the same day. Also, if there are people that would like to work ahead, I do these same videos every semester for all the different classes, including this one. And so you can look at the other videos I have from previous courses if people would like to work ahead. Not required, of course, but there is that option. Any other questions?
So I turned in my assignment already, but my test cases, I only did 3. Can I resubmit it?
Yep, you can just add additional test cases to it. And then if you just resubmit just that file that has your test cases in it, then I will be grading off of the last one that you submit.
Okay.
And one more thing I'd like to put out as well. I put this in the class announcements, but it kind of relates to your assignments. So when you submit your assignments, you can submit them as early as you want. You can start working on any of the assignments you want. I will not grade assignments until the day after the due date. That gives everybody a chance to get their assignments in by the due date. But if you do poorly on an assignment, whenever I give you your grade back, I will spell out, I will put on there specifically what you got wrong, what you received point deductions for. You have the opportunity to redo the assignment and submit it again. However, for assignments, we do have the late point penalty policy, right? It's in the syllabus and also posted on the course announcements. If you submit assignments late, then there is some point deductions associated with that. So, how that ties in with redoing an assignment is, as I said, if you did really poorly on assignment, you can look at my comments, you can fix your assignment, and you can submit it again, and I will regrade your assignment. However, the late penalty will apply to that. And what that means is, if I grade your assignment, if you fix up everything wrong with it and you submit it 2 days later or 2 days after the due date, then it will get completely regraded. However, you will have 2 days worth of late penalties applied to it. And that's how the resubmission process would work. So you can potentially do much, much better if you did poorly the first time. Let's say the first time, you got a 60 on the assignment. I'm just making up numbers here. And you're like, oh, you want to redo the assignment. So you redo the assignment and you submit it 2 days later. If you got everything right on the assignment during your resubmission, normally that would be 100. But if it was 2 days late, I think is like 6 points. It's in the syllabus. You'll have to look in the syllabus what the late point penalties are, but you could end up with a 94, significantly better than the 60 during your first submission, but it allows you to go back and fix any mistakes you have and resubmit it to potentially get a better grade. So that's open for all the assignments. It doesn't apply to the discussions. The discussions are just that 1 week and that's it. But for the assignments, if you don't do so well the first time, fix your mistakes and then resubmit it to have it graded again. All right. Any other questions? All right. Don't hear anything else. We'll go ahead and wrap this up, and I will get this video posted up later today and an email sent out to everyone. All right. Have a good rest of your weekend.
Thank you too, Professor.